Hello, this is Mr. Rasmussen with Algebra 2, Lesson 86. Looks like we have some graphing to do first on a number line, and then we have a problem which involves an irrational root, means we use the quadratic equation. Okay, let's hop into this in some review here at the beginning where we're graphing some lines. Excuse me. Instead of saying equal to, we have an inequality, which is where in this case x is anything less than 3, but we also have a domain here which further restricts it. So it's positive integers, none of the negative numbers. So I'm going to graph this. It's not equal to 3, so since it's integers, it doesn't equal any of the parts in between the whole numbers. So we actually start with 2 and put a solid circle there, 1, a solid circle there, and then when we get to 0, 0 is neither positive nor negative, so it does not include that. And that's my graph of example 1. All right, example 2 here, x is anything greater than negative 3, so it involves all reals, so let's put my negative 3 there. Since it's not equal to it, I won't fill in my circle, but I'll put an open circle there, showing that's where it starts. And then x is anything greater, so a solid line going to the right, showing that all these numbers are a part of it. Okay, as we get into some further things here, the negation is where we have a line through saying what it's not. And the easiest way to solve that is to then write what it is, which leads me to the trichotomy of the symbols. Tri meaning 3. We've got 3 different options between two numbers. They can either be equal to each other, the one can be less than the other, or the one can be greater than the other. And those are the only three options. So as we look at example 3 here, let's write what it is. If it's not less than and not equal to, then we could rewrite it as x is anything greater than negative 4. So the two options here, it says in this particular case, it's not the less than and it's not the equal to, therefore what it is that third one. Okay, so let's graph that, and then notice our domain is just the negative numbers. So x negative 4 is going to be right here, and x is anything larger than that, so moving to the right. It doesn't include negative 4, but it will include negative 3, negative 2, negative 1. However, when we get to 0, then it stops because our domain is only negative numbers, and once then they become 0 or positive. So there is our graph of example point 3. All right, let's look at example point 4. Once again, let's write what it is. So negative x plus 4, if it's not greater than, it must be less than and equal to 2. Then we want to get x by itself, so we're going to subtract 4 from both sides. That gives me a negative 2 over here. And write that out, didn't give myself quite enough space. And then we also got to get this negative away from that side. And so when we divide both sides by a negative 1 here, this sign, this inequality is actually going to flip. So we get x is anything greater than or equal to, and then negative 2 divided by a negative 1 is a positive 2. So just remember, when we divide by a negative, that inequality's got to flip to the other. All right, so now our domain is all reals, and so x is anything greater than or equal to 2. So let's put 2 on my number line there. It's equal to 2, so a solid dot, and it's anything greater than, so a line going to the right. Okay, let's work with this one here. I'm going to write down here because I ran out of space on the other one. Let's write what it is. Negative x minus 4. If it's not greater than or equal to, it must be less than negative 2, like that. Let's add 4 to both sides here to be able to work toward getting x by itself. So I now have negative x is anything less than 2. And then I'm going to divide both sides by a negative 1 to be able to get x by itself. So I get x. Remember, this sign has got to flip if I divide by a negative. And so 2 divided by a negative 1 is negative 2. All right. As I put that on my number line, it's not equal. Here's negative 2, but it's not equal to negative 2. And it is only integers, which means I don't have a solid line. And so x is anything larger than negative 2. So I start with negative 1, and then I get to 0, and I run out of negative numbers. And so that is simply my graph there with a solid dot on negative 1. Okay. That being said, let's move on to irrational roots. Now this looks, if you see the setup of this example here, 6, looks very similar to lesson 85 and what we were solving there with those equations. And so it is done similar, but then as we get into it, we got to do something a little different to continue to get our answer. First step, let's switch this around to make it equal to y. So I'm going to subtract y from, actually nope, I'm going to leave y right there and move my x over. So add an x to both sides. So I get y is equal to x plus 1. All right, and then once again, I want to substitute that in there. So x squared plus parentheses x plus 1 squared equals 9. My x plus 1 has to get multiplied by itself in the squared there, so I'm going to get x squared plus 1x plus 1. Oh, a little too far. There we go. So plus 1 down here. I add those, get x squared plus 2x plus 1 inside of there, and put that in for the spot. So let's write that out. 2x plus x squared plus 2x plus 1 equals 9. All right, what can I further simplify? Well, let's subtract a 1 from both sides, and that gives me an 8 over here. I can factor out, actually I can add these two, so 2x squared plus 2x equals 8. And let's see here, I can, well, if we continue in the same path, that we had yesterday, we would factor out, an x, correct? So if we took an x out, I get 2x plus 2 equals 8, and it's not equal to 0 over here. So I need to get this side equal to 0. So let's back up here a little bit. That method where you split them and make x only works if there's a 0 there. So let's move this over. I get 2x squared plus 2x, and then minus 8 equals 0. Now, if I were to factor, let's factor a 2 out because we can do that. So we get 2 parentheses x squared plus x minus 4 equals 0. And I got a problem, 2 equals, if I put 2 equals 0, that is not true, so that actually gets thrown out. And then if I try to factor this into 2 binomials and get 2 answers, it doesn't work. I can't get 2 numbers that multiply together to also add together and get a positive 1. So that leads me to use the quadratic equation that you've been writing out in your homework. So let me write that out here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over top of 2a. Alright, so remember I've got my a value here, my b value here, and my c value there. So I'm going to plug that in and actually use the quadratic equation to get my answer. Alright, so that's going to be negative, my b value is 1, plus or minus the square root 1 squared minus 4. My a value is also 1, and my c value is negative 4. And then on the bottom 2, and my a value is 1. So there we go. All right, so let's reduce some things here. 2 times 1 is 2, so that there. 1 times itself is also 1. So if I look at this guy here, I get negative 4 times 1 is negative 4. Negative 4 times negative 4 is 16. So I get negative 1 plus or minus square root of 1 plus 16 over top of 2. And so if I add these together, I get 17 in my square root. And so they actually write our answer as, so you got plus or minus there, so they write our answer as negative 1 plus square root of 17, and they separate that out as, since there's 2 terms here, they just write it as two fractions, and then my other answer is going to be negative 1/2 minus square root of 17 over 2, which is that plus and minus right there. Okay, that is my answer for x. And so now I actually got to come back up here and put that in and solve for y. And so y is going to be equal to my negative 1/2 plus square root of 17 over 2, and then plus 1. So my plus 1, basically I'm going to change that to 2 over 2 so that I can add my 2 fractions. This one is not a like term, so we wouldn't add it with that one, but add in front there. So negative 1/2 plus 2 over 2. Negative 1 plus 2 is a positive 1/2. So my y value, so here's my 1x value. My y value connected to that one is going to be 1/2 plus square root of 17 over 2. And you see in the book there, they write it as a coordinate pair. I'll write this one as a coordinate pair so we can see what that one looks like. All right, so this one here, I'll start writing it down here. Negative 1/2 minus 17 over 2, comma. And then once again, I take this part here and I add a 1, which is the same as 2 over 2, which when I add those, I get the same thing. So 1/2 minus 17 over 2, and my x value here and my y value there. Okay, and there's my 2 answers as done through the quadratic equation. All right, I'm going to work through the 2 practice problems, so feel free to pause the video and work through those, especially the second one there, as that's got a lot of things going on, to see if you can get that one correct. All right, practice problem A. First step, write what it is. Negative x is anything larger than 4, because the negation is less than or equal to, so I switched it there. And then once again, I got to get x by itself, so I'm going to divide by a negative 1 on both sides. So that gives me x is anything less than negative 4. All right, then it's not equal to the negative 4, but I'll write that in there as a starting place. My domain is simply integers, so x is anything less than negative 4, so I'm actually going to start with negative 5, and it's integers, so just solid dots, negative 6, and continue my line, negative 7, and then a line going this way to show that it's integers that just keep going in the left direction in the negative numbers. So there's my answer for graphed practice problem A. All right, practice problem B. Once again, let's get y by itself. So y is equal to, if I add an x to both sides, I get x plus 1. And then I want to square both of those so I can substitute it into my first equation. So x plus 1 times x plus 1 gives me x squared, and then across the top plus 1x, and then plus 1. Add those together, x squared plus 2x plus 1. All right, if I substitute that in, I get x squared plus 2x plus 1 equals 11. Subtract the 1 from both sides. I'm going to save myself a little bit of space here by doing that. Cancels there. We get a 10 over here. And I actually want to set this up so that it is equal to 0, right? So I'm going to actually bring that back over. We'll go that way with it. So these two are like terms. So 2x squared plus 2x minus 10 is equal to 0. I want to get it to be equal to 0. I can factor out, looks like I can factor out a 2. So I'll do that. I get 2 parentheses x squared plus x minus 5 equals 0. 2 equals 0 doesn't compute, doesn't make sense, so we throw that out. And then we get this here. If I could factor this into two, if I could factor that into two binomials, then like x and you know, minus 1 plus 5, if that would work, then I could get my answers that way, but it doesn't work because when I add them together, I can't get this middle term. Henceforth, we got to go to the quadratic equation. So I'm going to write that out again. Minus b plus or minus the square root of b squared minus 4ac over top of 2a. All right, and my a value is equal to 1, my b value is equal to 1, and my c value is equal to -5. So let's plug those values in. Looks like minus 1 plus or minus the square root of 1 squared minus 4 times 1 times -5 over top of 2 times 1. Okay, let's combine in here. My negative 4 times 1 is -4. -4 times 5 is 20. So then I get 1 plus 20. So -1 plus or minus the square root of 21 over top of 2 is equal to x. So let me write that out here on the bottom as we start our answers. I got -1/2 plus the square root of 21 over 2, comma, and then I got -1/2 minus the square root of 21 over 2 as my values for x for my two answers. Okay, now I've got to plug that back in and back into my equation that I changed there, y equals x plus 1. So basically we're going to take this and we're going to add 1 to it. So -1 plus 1, which is 2 over 2, once again is equal to -1 plus 2 is 1, so 1/2. So as I put that in, my second one is added. As I put that in there, my second values are going to be 1/2 plus square root of 21 over 2, and 1/2 minus, or 1/2 minus the square root of 21 over 2. And that's my y value, and my y value. So there's one answer for an x and y, and there's my other answer for the x and y. And you can certainly see some repetition there in that problem. Okay, if you need some help working through that, please feel free to give me a text. And otherwise, have a great day.